Welcome to our journey into the mind of one of the greatest physicists and mathematicians of all time, Isaac Newton. When we think of Newton, we often visualize an apple falling from a tree, leading to the discovery of gravity. But his contributions go far beyond that. Newton's inventions and discoveries have had a profound impact on our understanding of the world around us, shaping the scientific way of thinking. His work in physics and mathematics provided firm foundations for these fields, revolutionizing our comprehension of motion, light, and gravity. From his laws of motion to the theory of gravitation, from the nature of white light to the invention of the reflecting telescope, Newton's innovative thinking and relentless curiosity have left an indelible mark on science and human thought. Now let's delve into the world of Newton's inventions. Scene script. First, we explore Newton's crowning achievement, his laws of motion. Let's dive into Newton's first law of motion, often referred to as the law of inertia. It states that an object at rest stays at rest, and an object in motion stays in motion, unless acted upon by an external force. In simpler terms, it's like when you're sitting comfortably on your couch, you'll stay there until the smell of freshly baked cookies pulls you into the kitchen. Next, we have Newton's second law of motion. This law explains how the velocity of an object changes when it's subjected to an external force. It's all about acceleration, which is the rate at which an object changes its speed. The law is often summarized by the formula F equals m times a, where F represents force, m is mass, and a is acceleration. Think of it like this: the harder you kick a soccer ball, the faster it goes. That's Newton's second law in action. Finally, Newton's third law of motion. This one's a bit of a crowd pleaser. It states for every action, there's an equal and opposite reaction. This doesn't mean the reactions cancel each other out. Rather, they act on different objects. Imagine jumping off a boat. As you move forward, the boat moves backward. That's Newton's third law, making sure everything in the universe remains balanced. These three laws of motion revolutionized our understanding of the physical world. They provided a firm physical and mathematical foundation for physics, allowing scientists to predict the motion of everything from a falling apple to the planets orbiting the sun. These revolutionary laws set the stage for future scientific developments. Now, let us turn our gaze towards Newton's significant contributions to the field of optics. Isaac Newton's work in optics was groundbreaking, and one of his most notable discoveries was the composition of white light. Newton proposed that white light is not a single entity, but rather a combination of different colors, each with its distinct wavelength. He demonstrated this through a simple yet elegant experiment involving a prism. Imagine a beam of white light entering one side of a prism. As it emerges from the other side, it's no longer a single white beam. Instead, it spreads out into a beautiful array of colors: red, orange, yellow, green, blue, indigo, and violet. This array is what we call a spectrum. Newton showed us that white light is a blend of these colors, each bending or refracting by a different amount as they pass through the prism. But why does this matter? Well, Newton's discovery had a profound impact on astronomy. Before Newton, astronomers believed that the color of stars was due to the light being altered as it passed through Earth's atmosphere. But with Newton's understanding of the light spectrum, astronomers realized that the color of stars is actually due to their temperature. Hotter stars emit more blue and violet light, while cooler stars emit more red light. This knowledge is fundamental to our understanding of the universe. Newton's work in optics went beyond just the nature of light. He also invented the reflecting telescope, a significant advancement over previous designs. Instead of using lenses, which can distort light and create blurry images, a reflecting telescope uses mirrors to collect and focus light. This invention allowed for clearer and more detailed observations of the heavens, further advancing our understanding of the cosmos. Newton's work in optics forever changed the way we understand light and color. His discoveries continue to influence many fields of science today, from astronomy to color theory in art. Indeed, without Newton's prism, our understanding of the world would be a lot less colorful. Beyond discoveries, Newton was also a prolific inventor. His creative genius was not confined to theories and laws, but extended to practical devices that significantly advanced the course of scientific exploration and understanding. Consider the reflecting telescope, for example. Before Newton, astronomers relied on refracting telescopes which were limited by the color distortion they produced. But Newton, with his deep understanding of optics and light, invented a new kind of telescope. His reflecting telescope used mirrors instead of lenses, reducing color distortion and greatly enhancing the clarity and detail of celestial observations. This invention brought the stars closer to humanity and paved the way for future advancements in astronomy. Then there's the sextant, a critical navigational tool used by sailors to determine their position relative to the stars. Though not the original creator, Newton made significant improvements to the sextant, enhancing its accuracy and reliability. His work on the sextant made the high seas less daunting and more navigable, opening up new pathways for exploration and discovery. But perhaps one of Newton's most profound inventions was not a physical device but a mathematical method. Known as the method of fluxions, this was Newton's early take on what we now know as calculus. With this invention, Newton provided a new way of describing motion and change, breaking down complex phenomena into manageable, solvable equations. This invention has been fundamental to countless scientific and engineering breakthroughs, from physics to computer science. From the stars above to the mathematical equations on paper, Newton's inventions continue to shape our world. His legacy of innovation serves as a testament to the power of curiosity and the endless possibilities of the human mind. As we conclude our journey through Newton's world, it's clear that his impact on science and technology is immeasurable. We've delved into his groundbreaking laws of motion, which continue to form the bedrock of modern physics. We've shed light on his work in optics, revealing the nature of white light and its component color wavelengths. And of course, we've explored his inventive mind, from the creation of the reflecting telescope to the improvement of the sextant. Each of Newton's discoveries and inventions revolutionized our understanding of the world around us, laying the groundwork for future developments in science. His contributions to physics, mathematics, and astronomy widened the reaches of human thought and demonstrated the power of the scientific way of thinking. But Newton's legacy is not just about what he discovered or invented. It's about the spirit of curiosity and exploration he embodied, a spirit that continues to inspire scientists and thinkers around the world. Which of Newton's inventions fascinated you the most? Share your thoughts in the comments below. Until next time, keep exploring the wonders of science.